Okay, when the tangents are horizontal, it means that the dy dx is equal to 0. It means they are meeting at a point of stationary. So classify point A, B, C. All of them are stationary. A, B, C are stationary. And the difference between A, B, C are, you can see, A is the local maximum because it's local, not the maximum point. We don't have the maximum point. The maximum point is unlimited, right? And then B is the point of inflection. Why? Because it just goes 0 and going down again. So down and going down. So it is called inflection point. Okay. And C is the local minimum. We can see as easy as that. Local minimum. Okay, that's the idea. Draw a sign diagram for fx. Okay, sign diagram of fx. So you have to draw like this. So we have fx. Sign diagram means the positive or negative only. We have -4, 0, and 5, right? So start from below -4, it is negative, right? Going down, right? So the value of the y is negative. After it meet 4 to 0, it is positive, 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 and so on until 0, right? And then 0 until 5 is negative, right? And then 5 above is positive. See, I think it's quite simple. But the more challenging part is on part 2, the f accent, the gradient sign, right? So we also have 4, -4, 0, and 5 also, right? So, oh, I'm sorry. No, not -4. Look at the local. So this is the local maximum. So -2, and then point of inflection 0, and we have here 3, right? So look at the local. There you go. I almost forgot. Look at the locals and local maximum, minimum, and inflection. Local maximum, local minimum, and inflection point. So the difference between maximum and minimum is quite simple, right? You can see local maximum is where it is on top of the hill, for example, and this is on the bottom of the valley, for example. Okay, I just give you the simple understanding: valley, and this is hills, and inflection is just turn like this or like this. This is inflection point as well, going up, then going up. Okay, so start from -2 to the left, the gradient is positive, right? See, positive, positive, positive until 0, right? So from below -2, the gradient is negative, right? Because if we talk about f accent or the derivative, it is always about the gradient. From 2 until 0, it is negative, right? It's going down the hill. So sorry, this is positive, right? So going up, positive, positive until 0, and then going negative. After the 0, also going down until 3, right? So the gradient is also negative. Okay, after it 3, it is going up. See, it's going up, so it is positive. So this is the sign diagram of the gradient. So you have to look at the locals and mention the gradient, mention the sign, or find the sign of the gradient. Okay, find the sign of m, right? So if you look at the left side, it is going up, right? And then start from -2 going down, and 0 and going down also again. Okay, any questions so far for question number 1? This is only the application. You just see about you have to look at this kind of 3 kinds of stationary point: local maximum, local minimum, and also inflection point. Sorry, wait, give me a moment. Opening the Microsoft Word. Okay, there you go. I think I need to put it on the left side of the screen. Now, number 2 Fi. Okay, number 2, part Fi. Classify any stationary points, catch the function showing all important features. F and I, yeah. I copy everything. F and I. Okay, F and I. Wait. I think I need to erase this. Okay, there you go. Okay, now, sorry, it's so noisy. Wait, yeah. I need to remain focused, and also you. Okay, for each of the following function, find and classify any stationary point. So stationary point is happen when the f(x) and x is equals to 0, as always. And stationary can be maximum, minimum, or 0 when or inflection when we do the second derivative. Okay, inflection. So maximum when f(x) and x is negative, f double x less than 0, right? So remember, when if I have ax squared plus bx plus c, so y equals ax squared plus bx plus c, where a is positive, it is smiling, it is minimum, right? So when a is negative, it is frowning, and it is maximum. So when a is positive, it is minimum. When a is negative, it is maximum. So what you have to memorize is only that. Okay. Now, so the minimum when f(x) and x is more than 0, right, or positive. Inflection is where f double x and x, the second derivative, is equals to 0. Okay, so that's the idea. What is stationary point, and the second derivative is talking about whether it is maximum, minimum, or inflection. Okay, I just make the sign negative, positive, 0. Okay, now, so for question F, let's see. Y equals x power half plus 2, right? So when we want to find the stationary point, we need to do the first derivative. So y(x) is equals to half x power negative half plus 0. No need to think anything about the 2. Why it is negative? Because half minus 1, right? We already discussed about this previously. And it has to be always 0. This is the rules. 0 equals half, okay, square root x. So find and classify any stationary points, sketch the function showing all important features. I don't think in this equation we have the stationary point, right? Because if I do the cross multiplication, that will be so weird. 0 times 2 square root x equals 1, right? And 0 times anything is 0 equals 1. See? So no stationary point for question F. No stationary point at all. Let's see, let's prove with the calculation. I mean the GeoGebra thing. Okay, that's the best way to prove whether it has the stationary point or no. Okay, GeoGebra. Oh, this is so annoying. Y equals x half plus square root x plus 2. Okay, y equals square root x, see, plus 2. So you don't have any stationary point. It is always increasing, and so on and so on. This is the thing that you have to understand. So what is the important features? I think important features is quite simple, guys, girls. important feature needs x-intercept, right? Y-intercept and stationary point, where if it is any, okay, it is optional, stationary point. So only 3 parts. So x-intercept happen when y equals 0. So 0 equals square root x plus 2, right? Here, you just copy paste this, and then -2 equals square root x, and it has no stationary point. Why? Because square root. Oh wait, x is wait. I don't think we have this stationary point. Why? Because x equals 4, right? If I do the what do you call it? Square both sides. Let's see. See, no x-intercept at all. If you want to make sure, if you want to insist, keep the 4, it doesn't make sense at all, right? Because if you look at the square root x equals negative, it doesn't make sense because any square root has to be positive, right? So no x-intercept. And y-intercept is quite simple, where x equals 0, so y equals 0 plus 2, so 2 itself, so 0, 2, that's it. And then stationary point, no, and this is no. Okay, so the graph will be like this. Okay. Oh, this is higher derivatives. Okay, in my subject, I teach this as a higher derivatives. Still, this is number F, question 2, part F. How about part 2, part I? Okay, I will copy everything first because I don't have enough space here. Let me know whenever you have any question, ask me, because I need your feedback as well. Okay, part, what part? Oh, I, yeah. A moment, please. Okay, part I. So I don't want to delete the understanding on top. And what we need to do is try to calculate fx equals y, part I. Y equals 1 minus x times x power half. I make it simple. 1 minus x power 3 over 2, right? Because 1 plus 1.5, 1 plus half is 1.5, 1.5 is 3 over 2. And you can find the derivatives. Negative, the 1 is 0, okay, minus 3 over 2, x power 1 over 2, right? That's the way you have to do, right? You do the power and then subtract 1 of the power. It will be half. 0 equals -3 over 2 square root x, right? And then what you have to do, quite simple. You multiply by 2 because I hate the fraction. So 0 equals -3 square root x. I divide everything by -3 because I hate the negative. So 0 equals square root x, right? So we know that x equals to 0, right? This is the x stationary, okay? Stationary x, a stationary point. Stationary point is where x equals to 0, and then what is the y? If we get the x, y is, I just insert here, right? 1 minus 0 power 1 times 0 power half, 1 is half, right? So the stationary point is 0, 1. What is the feature? What is the further stationary point, whether it is maximum, minimum, or inflection? You need to do the second derivatives, okay? We have the first derivative here. I will simplify the first derivative. So y xn equals -3 over 2 times x power half. So the second derivative will equals to -3 over 2, right, times half. You do the derivatives, x power -half, and you put x as 0. Okay, so the second derivative is 0, right? Because if I substitute the x by 0 here, so -3 over 2 times 1 over 2 times 0 power half power -half is, oh, wait, it's so annoying, girls. Wait, here. So -3, oh, wait. Okay, I'm confused right now. So negative 3 over 4 square root x, right? So if I put 0 on bottom, it will be undefined, right? It is so negative, right? Get the idea? Negative 3 over near to 0 is negative 3 over something 0 is negative infinite, right? Negative infinite. Okay, it's infinite. So negative infinity. So when it is negative infinity, it means that local minimum. It's supposed to be like that, okay? So let's try to sketch the graph. Y equals 1 subtract x square root x. Oh man, there is no local at all. So there is no local minimum. So point 0, 1 here is the starting point, right? And then it going down like this. So we don't have any stationary point also. I think your teacher give you the trick question. Okay. So here, no stationary point. Undefined means it's even not a stationary point. Wait, what the? Why two of the question directly give you this kind of question, this kind of answer? I don't have any idea. But this is what we're gonna discuss. Okay, about the further derivative. Okay, let's do the next question. 5 until 7. Wow. Okay. Okay. I'm glad to hear to see this kind of question because this is pure algebra. Let's see number 5. Fx equals x cubed plus ax plus b has a stationary point at 2, 3. So again, stationary point is talking about the first derivative. So fx and x, right? And then equals 3x squared plus a only, right? Because b is a constant and ax, so a times 1 times x power 1 minus 1, b is a constant, so 0, ignore. And when it is stationary point, we write 0 on the stationary point. 3x squared plus a at x equals negative 2 and 3. So you have to focus on the negative 2. Put here 0 equals 3 times negative 2 square plus a. So you can find the value of a easily. So a with 0 equals 12 plus a. So a equals negative 12. Got it? A equals negative 12. After you get a equals negative 12, what you can do to find b, here, use this. Fx equals x cubed plus ax plus b. Okay, so fx equals 3 here because this is 3 equals x cubed negative 2 cubed plus a negative 12 times x plus b. You can find the b. So in order to find b, you need the help of fx. In order to find a, you need the help of the stationary point. Okay, so 3 equals negative 8 plus negative 12 times negative 2 is 24 plus b, right? So 3 plus 8 minus 24 equals b. Okay, next 3 plus 8, 11. 11 minus 24 is negative 13 equals b. Okay, so we get the value of a and of b already. Now find the position and nature of all stationary points. Okay, this is quite interesting. So let's do the next part. So fx equals x cubed minus 12x minus 13, right? So when we want to find the stationary point, again, you have to do the first derivative. Yxn equals 3x squared minus 12. And it has to be 0. 3 bracket x squared minus 4. 0 equals 3 bracket x plus 2, x minus 2. Do the factorization. And we have not only negative 2, but also 2, right? So this is when x equals -2. Here x equals 2. We have another stationary points. So the y is given already. It is 3, so you don't have to think about this. And the next y equals to, put it, right? We substitute here. 2 cubed minus 12 times 2 minus 13. So 8 minus 24 minus 13. What's the answer? It is negative. Okay, I hate this. Negative 16, negative 29, right? So we have two stationary points, -2, 3 and 2, negative 29. And the nature, what is the nature? It is either maximum, minimum, or inflection point. Now, for the nature, you need to find the second derivative. Okay, we have the first derivative, 3x squared minus 12, right? So the second derivative is 6x only. So if you input here, 6 times -2, right? So 6 times -2, oh, it is -12. So it is negative. So this nature are maximum, right? Because negative are maximum. But if I want to insert here 2, 6 times 2 is equals to 12. It is positive, so it is minimum local. Okay. If you want to prove, try. Prove with a calculator. Y equals x cubed minus 12x plus minus 13. There you go. See, the -2, 3 is maximum as it is given, and the negative will be here. No inflection point at all. Okay, it's proven, well proven, right? Here. There you go. See, it is proven, yeah. -2, 3 is maximum. -2, 2, -21 is minimum. Okay. So I think that's all for number 5.
Wait, so
Yes.
how do you know if it's maximum or minimum from the number?
Okay, maximum is where the second derivative is negative. See, it is -12, right? You insert the x by -2. If it is positive, means the nature of the stationary point is minimum. Get the idea? I think the book is already explained. Okay, there you go. If the second derivative is more than 0, it means positive. It is a local minimum, right? If the second derivative is less than 0, it means negative, so local maximum. If 0, it is an inflection point. Okay, it could be local maximum, local minimum, or stationary inflection. But I think it is inflection. Okay, always if it is 0, it is inflection point. Or can I think that's for the explanation. Yeah. Now it's number 6. Oh man. Okay, number 6 is so much. Wait, I haven't copied this. Let's do number 6. Okay. Okay. So much because we have 4 questions here. A, B, C, D. Find the position or nature of stationary point. So position means the first derivative is 0. If it is stationary point, the nature, it is talking about the second derivative. Okay, I will give the sign here. Y accent and Y double accent. Okay. Let's do this slowly. Question A. Y equals x times e power negative x, or x over e power x. You use the quotient rule, remember? Man, quotient rule. So u equals x, v equals e power x, u accent is 1, v accent, since it is a natural, e power x again. So we don't derive the e. So the y accent will equals to u accent v minus u v accent over v square, right? E power x minus x times e power x over e power 2x, right? Or e power x bracket square means e power x times 2, e power 2x. And it has to be 0, right? And then cross multiply, right? Because stationary point means the first derivative is equals to 0 as always. So 0 equals cross multiply e power x 1 minus x, right? I just factorize this part. I put the e power x out of the equation. So first thing first, x equals 1, right? And you get x equals 1. We know that the stationary point is y equals here. Y equals 1 times e power negative 1, or y equals 1 over e. You don't have to find the number. No need. Just this. If you want to find the number, just use calculator. So the stationary point will equals to 1, 1 over e. What is the nature now? The problem is, what is the nature? The nature of the stationary point is you need to derive one more time. You need to derive this. Oh, crazy, man. Okay, let's try. So y(x(n) equals e power x 1 minus x, right, over e power x. 2x means e power x also, right? We can cross this before we do the second derivative, because it's so hard if we don't do the second derivative with the simple version of the first derivative. Okay, now, so y(x(n) equals to 1 minus x over e power x. You do the other quotient rule. Oh man. U equals 1 minus x, v equals e power x again. So u(x(n) equals negative 1, right? And v(x(n) equals e power x only, or again, don't change the natural number, like I said before. And then u(x(n) v minus u v(x(n) over v squared. This is the second derivative. Do the second derivative one more time. Okay, next. Okay, it's so long. It's so time consuming, but I think in order to solve this question, to make it fast, I do 6a and 6b, because c is same with a, right? Because it's a quotient rule, and b is same with d because it is a multiplication rule. No, this is a quotient rule because, okay, later, yeah. So u(x(n) negative 1 times e power x minus u(v(x)(n), so e power x 1 minus x, right, over v square e power x power 2, or e power x times e power x. I think this is better. So y(x)(n) equals to, I want to get rid of negative e power x, and then 1 plus 1 minus x, right, over e power x times e power x, cross, right? And then what next? Negative 1 bracket, or negative bracket because it has the negative on the left side. 1 plus 1, 2 minus x over e power x. This is the second derivative, and we need to find the sign, whether it is positive or negative. So y derivative, second derivative, the x is equals to 1, right? So x equals 1. So negative 2 minus 1 over e power 1. Negative 1 over e power 1, negative. So when it is negative, so the nature of stationary point is maximum, right? So we do the long part, long working here for the second derivative just to find whether it is maximum, minimum, or inflection, right? And wasting time. But again, you have to do this long way. Okay. Now, B. Y equals x squared times e power x. I think it's quite simple because the product rule requires you the less working. Product rule, right? So when we want to find the product rule, you need to find the u x squared v e power x, right? Is it right? Yeah, it is. It is. U(x(n) equals 2x, right? V(x(n) equals e power x. The product rule formula, y(x(n) equals u(x(n) v plus u v(x(n), right? So here, 2x times e power x plus x squared times e power x. And we can simplify, get rid of the e power x times x, right? And 2 plus x. And then it has to be 0. E power x times x, 2 plus x. The x will equals to 0 and -2. Okay? So x is 0. Another x is -2. Okay, we have a lot of homework now. So the y will equals to, put it here, 0 times anything is 0, right? Now here, this is the more challenging part. Y equals, insert here. I think we need to use calculator to make it fast. Okay, I'm finding calculator so you can see what I'm doing right now. Education. Yes, Tedra?
What's the answer for A? I can't
Oh.
really, it looks like hay.
Yep. Okay. So find the position and nature of stationary point. So this is the answer, by the way. This is the point, and this is the nature maximum, right? Because it is negative, right? Get the idea? So first thing first, you need to find the stationary point. The rule of stationary point is where the y-axis is equals to 0, right? And you need to solve the x here. So 0 equals blah, 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 cross multiply, and the x equals to 1, right? After you get the x equals to 1, we have the x of stationary point. And then we need to find the y from this equation as well. So y equals x equals 1 times e power -1. E power -1 is 1 over e. So this is the stationary point. 1, 1 over e. And then to determine the nature, you need to find the second derivative. Okay, this is the second derivative. First derivative is 1 over x minus e power x over e power x, right? Because we simplify this, we can cross the factor. And then after you get the most basic version of the double derivative or the second derivative, you need to insert the value of x that we get from this. Okay, fine. Put it inside the x equals to 1, right? And then the sign is negative, right? Because -1 over something over e is negative. If it is negative, it means it has to be maximum. So this is the answer. Get it, Tedra?
Kind of. I think so.
Let me know whenever you have any further question, yeah. Because this is new for you because on Friday, Vicky said both of you didn't attend the class, right? Okay, so if x equals -2, you put insert. The y is here, right? X squared times e power x, x squared -2 square times, wait, the negative is supposed to be bracket, because I'm afraid the negative, yeah, there you go. X squared times e is located here, so the power of -2, right? You just copy this. Oh man, 0.54, okay, 0.54, just do the rounding. So both of them are stationary points, right? So this is a stationary point, and this also a stationary point. But to determine the nature, we need to do the second derivative. This is our first derivative, right? Oh my goodness, it is so annoying. Wait, there you go. We have, how many? We have one, multiplication. Okay. The double derivatives. Okay, the first derivative, I want to write it down first. E power x times, can I write like this? 2x plus x squared, right? So it will become 2 multiplication, right? So the u equals to e power x. the v equals 2x plus x squared, right? And then u xn will e power x as well. V xn will be 2 plus 2x. Oh, crazy. Y xn, u xn v plus u v xn using the same product rule. E power x times 2x plus x squared plus u v xn. E power x 2 plus 2x. And again, what you need to do is try to solve this, right? So if x equals to 0, the double derivative is equals to every x supposed to be changed into 0, right? I guess it is 0 also. No, not always. Okay, let's do e to the power of 0, right? And then multiply by 2 times 0. I put the bracket, and then plus 0 square. Okay. And then close the bracket, plus e to the power of 0 also. And then this one here, the right side, 2 plus 2 times 0. I don't think this is 0. See, 2, positive, right? So if it is positive, it is minimum. Okay, so this is the first answer. And then we have the other stationary point. You change the x by -2, and you need to find, okay, I think I need to give you the explanation here. So when x equals 0, the y-axis is positive, right? And then next, when x equals -2, what is the value of the double derivative? Again, you need the help of the calculator. You change every 0 by -2, right? -2, -2, every 0 by -2, -2. By the way, nothing to do with the result, but what we want to find is only about the sign, -0.27, right? Negative. So it has to be maximum. So this is the answer. Okay, the stationary points are 0, 0 for the nature of minimum, and -2, 0, -2, 0.54 with the local maximum. Okay. Now, for question C, it is similar with A, and for question D, it is similar with B. Okay, I don't think we need to I need to explain about this further. Okay, about C and D, I think you can do it on your own. By the way, this is not being marked, right? Not being marked, so you know the logic, and it is enough. Okay, after if we have more time, we can discuss 6 CD. Now number 7. Okay. The global, not local anymore. Okay. Let's see number 7. Consider fx equals x times ln x. What is the value of x if is fx divine? So we have to understand that ln, or natural log, cannot be negative. So for all values of x, a is quite simple, where x is more than or equal to 0, because ln x, x cannot be negative, right? That's it. That's the idea. A is simple question. Now we do the B. Show that the global minimum value of fx is -1/e. Okay, let's do this then. Minimum means the y-axis equals to 0. So first thing first, the y equals x times ln x. This is u, this is v. U equals x, v equals ln x, u xn equals 1, v xn equals, oh wait, 1/x, right? I think I'm not wrong. Okay, ln x. So product rule. Remember the derivative of ln x is 1 over x. That's the way. Okay, now y xn equals to u xn v, right? Plus u v xn. You are finding now the stationary point. 0 equals u xn v ln x plus x times 1 over x. Oh, plus 1. Okay, so ln x equals -1, right? It can be like this. What what is the connection between a and this? The value of ln can be negative, but the inside can never be negative. So to find x, this is I think you need to memorize the rule. X equals e power -1. Okay, e power -1. Okay, because if ln x equals a, the x will be e power a. This is the rule I'm taken here. So x equals 1 over e, right? And then after you get the x equals 1 over e, now you need to find the fx, right? The y. So y equals x times ln x as it is given on the question, and y equals 1 over e times ln 1 over e. Okay, use calculator. If you don't know the rule, use calculator better. 1 over e times ln 1 over e equals, see, -0.367. Okay, keep in mind -0.367. Okay, it's not the same, right? If it is not the same, you can try to prove. -1 over e is equals to this. See, it's the same, right? It's 368, yeah. Proven. -0.368 also. Okay, this is the global minimum. What is the difference between local minimum and global minimum? The global minimum means that's the total or the least number in a graph. If local, it lists for a while and it can be changed. It can be it is not a local minimum. It is not a global minimum. Okay, this is the global minimum. Okay, now number 10, BCD. Wow, okay, last 3 numbers. Oh, remember this trigonometry BCD, yeah? Are you guys not sleepy? It's almost 9.
Kind of.
I know. I usually sleep at 8 right now for some time. And 9 and 8:30 until 9. I don't know. I know I feel like a baby right now. For maybe after holiday, I slept like a baby. Okay, B. Y equals cos 2x. Remember, cos becomes negative sign and chain rule. Okay, find the position and the nature of the stationary point on interval 0 until x until 2x. So 0 less than equals to x less than equals to 2 pi. Okay, or 0 until 360. That's simple. And then show them on a graph of the function. Okay, up to you. Okay, find the second derivative. Cos becomes negative sign, right? And then don't forget to multiply by 2. Okay, that's the way, the inside. Remember, chain rule. So 0 equals negative sign 2x times 2, or I divide everything by wait. I think I can just write like this: 2 times sine 2x. So 0 equals sine 2x, right? I want to divide by -2. So 0 is sine 0. Remember, we need the help of the previous logic, the trigonometric equation. Okay, So, man, I need to, I forgot almost everything. There you go. The sine function. The circle thing, remember? Wait, the pi over something. Where's the circle? No. Wait, I think radian measure. Pi over 6 and pi over 4, remember? There you go. Wait. Yes, we need this. Extremely need this. Okay. Multiple of pi over 6 or multiple of 30. Remember this rule? I'm copying this to you. Also, the multiple of pi over 4. Wait. Or have you learned about the quadrant rule? If you learn about quadrant rule, I think that's more simple than you memorize this. Have you ever learned about that quadrant rule? Sine 0 equals sine 2x. So x can be, if sine 0, remember this is cos, this is sine. If the value of sine equals to 0, it can be -1. Wait. 0. Sine 0 is 0, right? Because 0 is here. So 2x equals to 0 and x equals 0 also. Or this, right? Or -1 or 180 degree. Get it? So 2x can also be 180 degree. So x is equals to 90. And we can find another. So this is the part of 0. This is the part of 180. And also this is 360 because we want to find the sine as 0 here. Sine 0 is located here. So 2x can also be 360. So x can be 180 degree, right? And 2x can also be 360 plus 180, 540. Okay, this is also 540 degree, right? And the x will equals to 270, and it is still in the range. Why? Because the range is 0 until 0 until 360, and if you go further, you don't find it will be more than 360, right? Because 2 pi is 360 degree. Okay, that's for question B. And then the nature. Okay, we forget to put the y. Y is always 0, right? Cos 2 times, oh wait, no. Cos 2 times x, so cos 0 is 1, right? And then y equals, okay, just put here. Look at the equation first thing, cos 2x, cos 2 times 90. Wait, I have to change into a degree, yeah? Degree 3, okay. I don't want to do the radian form, it's wasting time. And I don't get used to it at all. Okay, -1. If 180, it is 1. Oh, okay. It is up and down, right? If 270, that's proof. Wait, what happened? Oh man, what happened? Okay. The calculator is shutting down. I don't know why. Wait, I'm opening the calculator again. There you go. Cos 2 times 270. I bet this is -1. No, I forget. Degree. -1. See? Okay, so we don't have to find the second derivative. Why? No, this is not the first derivative. Give me a moment. This is not the second, this is the first. So I think we don't have to find the second derivative because we know that this is clearly seen. The y is 1, the y is -1, the y is 1, the y is -1. That's all. Okay. So the positive is maximum, the negative is minimum, the y, the value of y. If you don't believe, try to prove with calculator. Okay. So y equals cos 2x. There you go. See, -1, +1, -1, +1, -1, positive, negative, and we have so much what they call, so much stationary point because this is the wave function. Okay, that's for question B. Now question C, what the heck is sine square? Okay, let's see. The problem is only on the derivative. The y-axis, remember, the power 2 times sine x times the inside, times the what you call, times by the sine x becomes cos x. That's it. Okay, so 0 equals to sine x cos x. Okay, so sine x can be 0 or cos x can be 0. So x can be 0. How about this? X equals to 90. Or if sine equals 0, negative 180 also, right? Because this is the part of the sine that is 0. And the cos that is 0 is here, 90, right? This is the cos. So first is cos, second for the y-axis will be sine, or 170. So we have 4 also, 0, 180, no, sorry, 90, ascending rule, 90, 180, right? And then 270. So the y equals to, insert 0, sine square 1, 1, sine square 180, 0, 1. Okay. If you want to prove with calculator, again, you can use calculator. And you can see 0, 1, 0, 1. Okay, so this will be minimum. This will be maximum. See, the lower part is minimum because this is stationary. Stationary is always extreme, either minimum, maximum, or inflection. In the trigonometrical part, in trigonometric function, we don't know, we don't have the inflection point. Min, max. Let's prove with calculator. Sine square x with the GeoGebra. See, 0, 1, 0, 1, 0, 1. Okay, so it is proven. Now we know the position and also the nature. It's quite simple, but for question D later, I think I need to, I think I can delete this. Okay, so this is the answer, yeah, the nature and the maximum minimum. Not in radian form, of course. This is in the degree because that's the most basic part. If you want to convert into radian, up to you for the x only. Okay. Let's do part D. Remember the rules? Remember the rule y equals e power functions of x. So the y-axis equals the number itself, e power function of x times the inside, or times the derivative of the power. That's for question D. So y-axis equals to e power sine x times sine x becomes cos x, right? That's it. And put 0. E power sine x times cos x. So what we can find is only cos x. Cos x equals to 0. If cos x equals to 0, we can find this. Okay, it's given. So you don't have to work twice. Work smart. 90 here as it is given. X equals 270. How about this? E power sin x equals 0. So sin x equals negative undefined. So doesn't make sense. I think it doesn't make sense. Any questions so far? I think someone unmute.
Sorry.
Okay.
Why do you multiply cos x? Is it like, oh yeah. Okay, never
On
mind.
the top right. Okay, here. Okay. Get it? That's the rule. Okay, let's try to prove. Honestly, for question D, I'm not sure about that. Let's see. It is only 90 and 270. Wait, man. I need to change the value of x. Settings. The x-axis is in terms of pi. There you go. Pi is 180, 2 pi is 360. Yeah, keep in mind. Let's try to solve. Y equals e power sin x. Y equals e. No, not this e. E power sin x. Oh yeah, cool. 90, right? This is pi over 2. 90, the maximum. Oh, I forgot to put the y. Wait. So the y equals, let's put on the equation, e to the power of sine 90. 2.1772. And how about if I change the 90, it becomes 270. Also 0.36, 0.37. Okay, let's prove. This is maximum, of course, because the bigger y, and this is the minimum. So you don't have to write the second derivative wasting time, because we already proved in the calculator. See, it's 2.72, right? 2.718, blah, blah, blah. And this will be 0.36 is the minimum. Okay, see, the graph is quite like the wave here, like the ocean wave. Not so, this is not, what do you call it? In a geometric shape. It is not a good shape, but this is the real E. Okay, so it is proven. The maximum is 2.71 and the minimum is 0.37. Okay, so what is the answer? That's the answer here. So x and y is the point of the stationary points, and then max min is the nature, local maximum, or I think that's global. Why? Because nothing less than the minimum and nothing more than the maximum. Okay, number 10 done. Wait, what more? What number? What else? Okay, done. So let's do number 6. I think number 6 we can do. I think you can do it on your own. Yeah. Wait. Hey, where is it? There you go. Okay, 6C and D, I think you can do it on your own because we have the A and B already. Okay, so I wish you good luck for tomorrow. I hope you can answer the basic idea of what your teacher of what is the homework tried to tell you about. Okay, any questions so far, Tedra, Vicky?